My name is Steve Jollymore. This is my online instructional video for PIDP 3240 Assignment 5. The topic is how to balance a heat recovery ventilator. Inadequate ventilation can be a health and safety concern for your family with long-term effects that may not be seen for years when it's too late. Without adequate ventilation, occupants are subjected to higher levels of carbon dioxide and chemicals from off-gassing of building materials. Table 93235 from the BC Building Code shows a 4,500 square foot home with 4 bedrooms has a ventilation requirement of 89 cubic feet per minute. The fan performance chart found in the product specifications of the selected equipment shows we can exchange approximately 103 cubic feet per minute at 0.40 inches water column by selecting high 2. Set the fan speed according to the manufacturer's instructions found in the installation manual, typically with dip switches. By turning dip switch 3 off and switch 4 on, we have selected high 2. To prepare the home for balancing, close windows, doors, and flues. Turn off intermittent ventilation. Fully open all grills and diffusers. Prime the P-trap with water to keep the supply and exhaust airstream separated. Turn the HRV to the selected ventilation speed. We'll start by balancing the air exhausted from the building to make it even with the supply air brought into the building. You will throttle down the higher one. By exhausting the same amount of air as we bring in, we achieve balanced ventilation. This will reduce the infiltration for your home, lowering your energy costs. Most HRVs are equipped with ports on the door and dampers for the balancing. If the equipment you are installing does not have them, you have to add dampers and measure the airflow using a flow grid or pitot tube. Check with your manufacturer for instructions on the equipment you are working with. With the door open on this HRV, we see that the ports are measuring the pressure on each side of the exhaust fan to determine the exhaust flow rate. The ports for the supply are measuring the pressure on both sides of the supply fan to determine the supply flow rate. We measure 0.60 inches water column for the exhaust pressure using a digital differential manometer. Flowcharts are found in the equipment's installation manual. We see that for exhaust, 0.60 inches water column is 106 cubic feet per minute of airflow. We measure a pressure of 0.68 inches water column for the supply. The chart from the installation manual shows the volume of 109 cubic feet per minute for the supply. The volume of air supplied for ventilation must be within 10% of the air exhausted from the home. 106 cubic feet per minute of exhaust is 3 CFM less than 109 for the supply, well within the 10% range. A flow grid is a measuring device used to measure airflow. This device measures the absolute pressure and the static pressure to determine the velocity pressure. Flow grids average the readings through the cross-section of the pipe, so they're not as susceptible to erratic readings from dirty air caused by turbulence as a pitot tube. Using the charts provided by the manufacturer of the flow grid, we can determine the volume of the airflow by matching the velocity pressure to the volume. We see that 0.25 inches water column is 34 cubic feet per minute. We see that 0.10 is 21 cubic feet per minute. Closing the damper increases the static pressure, which reduces the velocity pressure, meaning less airflow. Insert the static pressure probes in the ductwork with the tips facing the airflow. To measure the external static pressure, place one in the exhaust between the HRV and outside, the other in the exhaust between the exhaust grills and the HRV. Do the same for the supply side of the system. Measure with a differential pressure gauge like a magnehelic or electronic manometer. Make sure the pressure is within 0.40 inches water column. Once the home is completed, balance the zones using an air hood. You'll have to do multiple measurements for each zone. Reducing airflow in one zone will affect the other zones. Every time you touch a damper, it affects airflow everywhere in the system. Confirm all zones are balanced for the designed airflow, checking every grill or diffuser without further adjustment for all zones. If the code requirement for the ventilation exhaust from a bathroom is being satisfied by the HRV, confirm it's exhausting no less than 20 cubic feet per minute continuously.